Welcome to EyeOpener, powered by Siemens. And now, your host, Gugan Sanger.
I think that's a really great point, Johnathan, around having complete transparency in terms of the operation and what's going on. So at least you can understand your assets and you can understand the data, and you've got all of that going on, which helps to...
Yeah, especially when you're looking at an entire production line.
Yeah.
From start to finish, you have full coverage. Because if you're looking only at a portion of the line or only the critical high value assets on a line, that's fine. It's good to do. But other smaller insignificant things could still affect your production output.
Okay.
And effectively in any manufacturing facility, that is what you want. It's the end of the product coming out of the line. So if you have full coverage, you can make sure there aren't any bottlenecks, aren't any small things that still will stop your production line.
Okay.
You can really look at the entire line's worth of reliability rather than just critical components that may or may not fail.
Okay, fine. And what would be examples of those smaller little problems that you may encounter?
So let's say a conveyor, for example. The conveyor's purpose is to move box from point A to point B. It's not particularly high cost. It doesn't have any fancy operating states or any operational change. But it is also a key point of the transportation of the product. So before it can get off the line, before it's a finished product, it's being transported from here to there. And if that goes down, it doesn't matter how fancy or how well everything else is performing and operating, there is your bottleneck. This goes down, you stop the production. So now you need to come in, first do a failure analysis, find out what's happened, why has it failed, what is the reasoning. Then go find, do we have the spares in stock?
Yeah.
Can we safely repair this asset now? Do we need work permits? So there's a full process, full range of processes in place that you need to do before you can fix this. Whereas if you had good indication that something was changing, something was degrading, you could have planned in this repair long before it happened.
Yeah.
So you can make sure that you have the right spares, that you have the right skill sets on site to do this work, that it's you do the repair at a time when production allows. So whether that's a weekend shut or your planned maintenance interval that you have, you can really plan in this to have the least impact and be done at the best time.
Okay, I understand. So I guess from a Senseye predictive maintenance perspective, how can the software help support the need for data?
Well, within the application itself, we have this very useful functionality called derived measures.
Okay.
It allows you to take two or more inputs and through whatever mathematical equation you can imagine to apply, you can then create an output. So you derive a measure or a virtual sensor. This is extremely useful if we look at the existing infrastructure, for example, if we're getting data from an existing infrastructure, you may have two measures, a motor current and speed.
Okay.
And just as measures themselves, yes, they're useful. But now we can start to build relationships between them. We can start to apply and derive further measures from this. If we look at pressures, an input and an output pressure, for example, maybe we want to know the difference between your delta. So we can derive that as a measure and monitor the difference between the two inputted measures. So the application's got that functionality within itself. But as a company, we are very much geared to guide our clients to the right type of hardware. So not only do myself and my team assist with this, we've got all of our delivery engineers are highly skilled and very, very experienced. They understand what other customers have used and other clients have used. They have their own real-world experience. So we very much guide our clients through the process of identifying what data is required, and then we can help them assess what hardware is then going to be installed. At the end of the day, for the Senseye Predictive Maintenance application, the hardware or where the data comes from is irrelevant. It's the quality of data. And that for us is the key factor that we always try and work towards, making sure we have good quality data, regardless of where it comes from.
Okay, brilliant. And I guess it is a combination between the two, isn't it? The people and the actual software that we have, which can help support. And I think when it comes to predictive maintenance and looking into existing infrastructure and additional hardware, I think it's that wealth of knowledge, isn't it? Having the right people there to support you, who can assist with what's going wrong, how we can avoid the failure. You know, if there is need for additional hardware to be installed, then you've got that support available.
Yeah, absolutely. So if I look at my experience, I spent 10 years, just over 10 years, as a condition monitoring engineer.
Okay.
So I'm certified and experienced in vibration analysis, oil and fuel analysis, thermography, and ultrasound. So when I go into an industrial environment, because I've worked in almost every industrial sector around, I'm familiar with the assets. I'm familiar with the processes. I understand what is unique between a motor in a chocolate factory and a motor in an automotive factory.
Yeah.
And that really does help me assess what type of data is going to be required, and then what type of sensing will be required.
Okay. So it is very much dependent on different industries as well, right?
Yes. Every industry has their nuanced differences. You know, it can be quite frustrating at times because someone says, do you have a use case? Do you have success cases from my industry? And we go, but a motor is a motor is a motor.
Yeah.
But there are differences. There are differences in the way that these motors will be used, the way that they're going to be run, what it is that they're driving, the operational changes that they have. Some industries, you'll have lines that just chug on at a steady state, and others that have constant changing speed.
How would you decide whether or not to invest into hardware?
So I was recently asked to scope out a sensing solution for slow rotating equipment. Now, slow rotating equipment is quite hard to monitor because normal vibration doesn't cover that.
Okay.
A vibration works off of, if you look at the frequency ranges, it starts really from about 10 hertz upwards, and you're looking at rotations of, let's say, 300 RPM. That's your starting speed. This is, the application I was asked to scope out for was 30 RPM.
Okay.
So very slow speed. Traditional vibration monitoring wasn't going to cut it. So I eventually scoped out a solution, found sensing, found a company, found the right sensing for it. And to cover one machine, so we would have 8 sensors, your data acquisition device, and whatever mechanism was required, like a gateway to push data through to the cloud, we're looking at tens of thousands of dollars. So it's extremely expensive. So really for the client, that is not, the cost versus benefit ratio is not there. However, if you do have a machine that is worth millions at a slow rotating speed, the impact of downtime to your production and to your output is extremely high, then of course that makes sense. It's a fraction of the cost it would be if it were to go down.
Yeah.
But in other cases, you know, people will have spares and components available. They may have an entire unit as spare or redundant that they could quickly swap out. The impact to production isn't there. So you really need to assess, what is the value of this? Does it make sense for me to invest this amount of money on this? What is the negative outcome if I didn't have it?
Yeah.
And is there any other hardware solution that could cover this? Maybe there's a cheaper supplier out there that has exactly the same outputs, exactly the same hardware, exactly the same quality standards, and so on. So yeah, you really need to think around, what is my benefit for this?
Yeah, exactly. And I guess it can be, from a cost implication perspective, it can be very expensive. But I guess it really depends, like you mentioned, on the value and the focus and what it brings to the table, right? Yeah. And I guess inevitably when it comes to, the need for data, I think a lot of individuals really just want that assistance to help. Yeah. For them to understand what they currently have at the moment, and then to have a specialist who can then turn around and say, well, this is what you have, but this would be better to help this process. Yeah. So it's a long-term goal and focus.
Yeah, absolutely. And we are working with one of the other business units within Siemens.
Okay.
and they are working with a client who is redoing the infrastructure, complete redo of the automation, new assets, new lines, new everything. And they're interested in Sensei, but they're not there yet.
Okay.
So they're waiting for this upgrade. Now, what we're doing is we're working with this other business unit to make sure that in their investigation, the proposals that they submit, as well as the execution of this, the upgrade for the infrastructure and automation, that they are future-proofing it for predictive maintenance.
Okay.
That when they're installing, they, yes, will get the necessary measures through PLCs, but that they're also making the useful data for us available for a later stage.
Okay.
So really different business departments working together as specialists to make sure that the client is not only happy with their immediate need, but that they are future-proofed for predictive maintenance at a later stage. And I can really see that level of speciality, that level of service, that the assistance that we're giving to the client is greatly appreciated.
So in terms of current trends, because I guess in regards to anything, there's always trends which appear. So from a client perspective, is there anything that you've seen recently in the last couple months which has been a focus for what they're looking to install and what they would like?
Yeah, so I think as technology gets better and better on a daily rate now, there are new technologies that people want, that they want to test out for whatever reason. So typically it's previously we would have had just wired sensors. So a sensor that was wired, the wiring would be your data path, but it also could be supplying power to the sensor itself. With technology now, Bluetooth sensing and wireless Bluetooth sensing is extremely popular.
Okay.
So everything, you place the sensor on, it has a certain amount of battery life, 2 to 5 years roughly, depending on your sampling frequency rates. And that will go to data acquisition device, and that will then get pushed to the cloud. So those are particularly useful when you don't want to have the wiring costs and the additional installation costs. So very useful. Downside of them is you have to change the batteries ever so often.
Okay.
Also, depending on the size of the environment you want to put sensing on, depending on what you have in the way, you have to think around how far away can my sensor be from the data acquisition? Is there something in the way that's blocking that data path? There's also technologies such as mesh technologies where every sensor acts as a data acquisition device and a transmission path. So you can actually extend the range between your gateway and the sensors. You can mesh them all together in a network and use that as a path through. There's also technologies like LoRaWAN that are out there. So yeah, I would definitely say there's been a lot of focus on wireless technology and the increase in that, and it is getting very good.
Yeah.
But for steady, reliable data acquisition, wired is
the best. Yeah. Exactly.
It is still a way to go for now. But
Okay.
I definitely think the wireless technologies are going to get good. Well, the wireless technologies are going to get good enough very soon where it's just going to be the way to go because of the ease of installation, reduced cost, and their reliability.
Exactly. And that's synchronized with the way technology operates now. Even when it comes from a wireless Bluetooth perspective, we use that in our day-to-day life, don't we? So when it comes to predictive maintenance, I guess the need to want to have wireless sensors and installation to be wireless and Bluetooth, there seems to be much more of an increasing demand, like you mentioned.
Absolutely. And I think any project manager will want to have the state-of-the-art solution installed.
Yeah.
People want to use technology for the betterment of their lives, and it's completely natural to want to be, at the forefront with the trends that are going on.
Yeah.
But again, you need to always think about what is your use case here. What am I trying to achieve? Start with the desired outcome, and work your way back to find out what type of technology is going to be useful. What is it you need to use?
So, Johnathan, on our previous episode, Christina asked a question for our next guest on the show. And that question is around whether or not you think artificial intelligence should be regulated.
It seems like a very simple question, but it's actually extremely tough. I think I, like most people, have had the benefit of using ChatGPT to give me a structure, give me the baseline for something I didn't know how to do. But I also see the difficulties that, let's say, lecturers or teachers are having, where a huge portion, or at least they believe a huge portion of their students are using AI to generate answers for school. So, it's always tough. There's the ease that AI brings, the ease to your daily life, but there's also the lack of responsibility that gives. So I don't know how, but yes, I believe it should, especially around the educational sectors. I do think that students of all ages, all over the world, need to be responsible for the content that they create. It really shows that they have put the effort, the time, the learning into the subject. But I also think it's very useful to learn or be able to do something that you don't particularly know how to do, or you're not very good at, as long as you use it in the right way.
The right way, yeah. Of course.
So yes, I think it should, especially around the educational sectors.
Okay.
But how that happens, who knows?
That's a really great answer. Thank you. And then I guess from your perspective, if you could ask our next guest on the show a question, what would it be?
How do they think technology and AI is being used to unite the world from its regions? Different countries, different geographic locations. Is it being used to unite or separate?
Okay. Very interesting question. Perfect. Well, thank you very much, Johnathan, for joining me on today's episode. Really enjoyed your insights into this whole topic around predictive maintenance and the need for data. Thank you again.
Thank you.
A big thank you to our audience for tuning in on today's episode. Please like and subscribe to our channel and stay tuned for the next one in the series. Thank you.
To find out more, search Sensei Predictive Maintenance.